Alright, so we're going to pick up our next section now with the female reproductive tract. So we're going to talk not only about the ovaries and oogenesis, but also, again, some of the accessory structures located throughout. So starting off with the ovaries now, primary function of the ovaries is to produce the oocytes, which is one of the most awkward words you'll ever hear or say probably. But oocytes are produced through oogenesis in the ovaries as part of what's called a follicle. So it turns out with the production of egg cells, it's not just the egg cells themselves that have to be produced, it's also these supporting other accessory cells that collectively, together with the egg cell, become part of what's called a follicle. And so with that follicle, we're going to actually have egg cells released. The fimbria, these structures here, are going to pull the egg cell out of the ovary into the uterine tube, which is sometimes also called a fallopian tube. And the remaining accessory cells left behind are going to continue to produce things like estrogen, to allow for the continued development of the egg cell, as well as preparation of the female's reproductive tract, uterus in particular, for the arrival of perhaps a zygote, if a zygote is produced. So now the process of oogenesis is fairly similar to what we saw in males. The overall idea is very similar, but there's a couple of really important distinctions that I want to point your attention to. So before we go through this process, what I want to kind of talk about is the relative contribution in terms of energy of females versus males toward the production of offspring. So I mentioned before how the sperm cell, all that really adds to the zygote is genetic material. It's DNA, it's chromosomes, and that's hugely important because you can't have a zygote without the male's chromosomes. But the egg cell not only has to add chromosomes to the mix, but it also has to add cytoplasm, it has to add nutrients, it has to add organelles. They're going to become part of the zygote. All of those things come from the egg cells. The egg cell is going to have to be relatively large. Now, if you're going to produce cells through the process of meiosis, one strategy would be to take one cell and divide it up into what amount to 4 equally sized smaller cells. And that's what happens more or less with the production of sperm cells. Another option would be to go through meiosis, make 4 cells, but make one of those cells much bigger than the other 3, and use that one as your primary source of, and what in this case will become the zygote, and that's exactly what happens. So let's take a look at oogenesis. Within the ovary, there is what's called an oogonium. So previously we saw a spermatogonium, now we're going to look at an oogonium. It's going to divide through mitosis, and it's going to produce eventually what's called a primary oocyte. And that primary oocyte, just like the primary spermatocyte was, is diploid, and it's going to go through meiosis 1. Now, one other really important distinction between male spermatogenesis and female oogenesis is the timing of the process. Right? So in males, spermatogenesis starts during puberty and ends when the individual dies, more or less. In oogenesis, this initial round of first mitosis and then meiosis 1 happens way before you're ever born. So it's not at puberty. It's not, several years after you're born. It's actually happening several weeks, even several months before you're ever even born. So this all happens during gestation of a female individual. So meiosis 1 occurs, is going to produce what are called secondary oocytes, and also a structure called a polar body. So if we look over here, we've got oogonia dividing through mitosis to produce, again, another oogonium and a primary oocyte. Primary oocyte goes through meiosis 1 to produce a secondary oocyte, which is relatively large still. And then in comparison, this is actually not drawn to scale, this is actually typically much smaller than is shown here, is a polar body. And a polar body is nothing more than a set of discarded chromosomes. The chromosomes that were not packaged into the secondary oocyte are packaged into a polar body, and that polar body, once it eventually goes through meiosis 2, is going to be broken down and not really used for anything. It's not actually a contribution at all to the reproductive process. Those chromosomes in those cells are just broken down. Alright, so eventually we have to take this secondary oocyte and run it through meiosis 2 as well to produce an egg cell and another polar body. So the end result of this is one egg cell and 3 very, very tiny polar bodies. But when does meiosis 2 occur? Well, meiosis 2 doesn't occur until after fertilization. Okay, so it's not until after a sperm cell has penetrated the egg cell and fused with it that we actually see meiosis 2 occurring and the production of an egg cell from a secondary oocyte. So it's, in some cases, you might be looking at, let's see, we said female puberty happens beginning at possibly age 8, going up until maybe age 11 or 12. So we are looking at a minimum, right, of at least 8 to 12 years between meiosis 1 and meiosis II. And that would be if you were reproducing at 8 to 12 years of age. And of course, most people don't do that. So biologically, I suppose it's possible. Socially, culturally, probably not so acceptable. But at a minimum, bare minimum of 8 to 12 years, that eventually egg cell is sitting there on the shelf waiting to be fertilized, waiting to go through meiosis II, waiting to produce what eventually will become an actual egg cell. Okay, so if you look at the other side of the spectrum, the other extreme, I guess you could say, if you're a mom who conceives at the age of 40, well, now that egg cell has been sitting on the shelf for just north of 40 years. And it's probably not too surprising then that single cells in your body that have been hanging out waiting for the past 30 or 40 years might experience some damage. They might start to go bad. And so as the age of mom especially increases, the possibility and likelihood of having abnormalities in the development process, the possibility of Down syndrome, for example, greatly increases with the age of the mother because these cells have been sitting around waiting for so long before they're actually fertilized. They perhaps have incurred damage along the way and they're not working quite as well as they should. So again, the end result of this is one egg cell and a grand total of 3 polar bodies, which are not used in fertilization, but are just leftover remnants of chromosomes that weren't packaged into an egg cell. So that now the egg cell is actually surrounded by, or what will become the egg cell, is surrounded by a layer of other cells that are nourishing, they're supporting the eventual egg cell, they're secreting the female sex hormones, estrogen and progesterone. They are part of what's called a follicle. So the oocyte, secondary oocyte, plus the accessory cells are called a follicle. Now it takes about 28 days for a follicle to mature. So if you look in either ovary at any given point in time, there will be a range of follicles at a range of level of maturity along their way to becoming eventually to the point where they can experience ovulation. This process is very much in tune with production of LH and FSH, just like we saw spermatogenesis in males. It also affects females with their oogenesis, as well as GnRH does as well. Estrogen production is very important. Progesterone is important as well for stimulating uterine development. The endometrial lining of the uterus, which is the place where the eventual zygote could implant if a zygote is formed, that uterine lining has to be stimulated by production of estrogen and especially progesterone. And if those aren't there, then the uterine lining is lost, and that's what you refer to as menstruation. All right, so the ovulation process itself. The secondary oocyte eventually leaves the follicle. It actually ruptures the follicle during ovulation. And so these fimbria, again, are responsible for pulling that secondary oocyte out of the follicle, out of the ovary, into the uterine tube. The secondary oocyte is now inside the uterine tube. And again, when I say uterine tube, that's the same as fallopian tube. If you know that term, that's perfectly acceptable. That's fine. What's left behind, what used to be a follicle, essentially the follicle minus the egg cell, is called the corpus luteum. And the corpus luteum is around for about 4 or 5 days, give or take, at which point it degrades and eventually is reabsorbed by the body. Right? So during the time when it's active, during the time that 4 or 5 days when it's still functional, the corpus luteum is going to secrete estrogen, it's going to secrete progesterone, and those 2 hormones are going to help maintain the uterine lining should a zygote be produced. If a zygote is produced, it needs to have a place to implant so it can be protected and nourished and be able to grow. And that function is taken on by both estrogen and progesterone. So we take a look here at kind of the progression during the roughly 28 days of the menstrual cycle. Beginning here in day 1, we have follicle cells, various follicle cells. We've got a primary oocyte, which is going through the progression here. Eventually we have our first polar body and our secondary oocyte over here. Eventually during around day 14 or so, that's where ovulation occurs during the 28-day cycle. It's right around day 14. So the follicle is ruptured, the secondary oocyte is released, and now what's left behind, this mass of cells back here, is the corpus luteum. So during this period of time from day 14 all the way through here, there is an egg cell that is able to be fertilized. Now eventually that follicle is going to start to degrade, or the corpus luteum is going to start to degrade. And so by the time we get out here to day 28, the corpus luteum is degenerated, the progesterone and estrogen levels have dropped, and because of that the endometrial lining is being shed from the uterus, and that's what initiates menstruation. Okay, so that's kind of the end of that month's 28-day cycle. Alright, so we talked about uterine tubes. We talked about the fimbria, sweeping the ovulated egg out of the follicle, out of the ovary, into the uterine tube. This is where fertilization occurs. Now, I've taught this course or other courses like it for a number of years now. One of the things that I found that a lot of people really don't fully understand is where fertilization takes place. People have all kinds of very creative ideas about where they think fertilization might actually happen, but this is it. This is the place. The uterine tube is where fertilization occurs. And so because of cilia, they're kind of continuously doing this sweeping motion. This now zygote, if a sperm cell has fertilized the egg cell, we now have a zygote, is going to move onwards down toward the uterus, where it can eventually implant. Now the uterus is made up of a couple of layers of tissue here. We have an endometrial lining. This is the inner layer. This is a layer where eventually the zygote will implant. It's very, very rich in blood vessels, and this is also the part of the uterus that's going to contribute to the female's contribution to the placenta. Placenta is a combination of both embryonic tissue as well as maternal tissue. So mom's contribution is going to be the endometrial lining of the uterus. The myometrial lining is below the endometrial lining. It's smooth muscle. And because it's smooth muscle, we know kind of how that muscle works. It's involuntary, it's non-striated, it's strong, slow, continuous contractions. This is what actually happens during childbirth. The myometrial lining is the layer of muscle that's responsible for childbirth, also the layer of muscle that's responsible for uterine cramping during menstruation. That's the other layer of uterine lining. The cervix is the lower part of the uterus, which helps keep a fetus in place if a fetus is present. It's kind of the part where eventually, once dilation occurs, the fetus will pass through on its way on out through the birth canal. And then, of course, the vagina or birth canal itself is where eventually the fetus, the infant, will eventually exit the body. Okay, so next up we're going to take a look at the menstrual cycle itself. We mentioned before it's approximately, on average for a human female, 28-day cycle. It's not that way for everybody exactly 28 days. There's variation from person to person. But we have a lot of things happening here. We have maturation of the oocyte. We have the egg really being released from the ovary. Right? So secondary oocyte released from the ovary. We also can call that an egg. It's more or less the same thing. Is released from the ovary. We have development of the endometrial lining in anticipation of a zygote being produced for implantation. And again, this is under hormonal control. And we're going to take a look at this and see exactly which hormones contribute when to various aspects of the menstrual cycle. So it starts again with GnRH, as it did in males with spermatogenesis. Now we have GnRH from the hypothalamus stimulating FSH and LH production from the anterior pituitary in females. Those two hormones are then going to have an effect on follicle development. And as the follicle matures, it's going to continue to produce estrogen. Now together, those three hormones, the FSH, LH, and estrogen, are going to help the follicle continue to mature, reach maturity, and actually get to the point where ovulation can occur at around day 14. As the follicle gets bigger, estrogen levels are increased, and as estrogen levels increase, follicle grows even more. So this is a bit of like a mini positive feedback cycle. More estrogen, more follicle, more estrogen, back and forth until eventually ovulation occurs at around day 14. So that's kind of the peak where ovulation happens, and then for approximately a week or so after that, fertilization is possible. LH, luteinizing hormone, is also going to help the follicle reach the point where it can achieve ovulation at day 14 and enter into that uterine tube. And like I said before, the corpus luteum, which is left behind, the follicle minus the secondary oocyte, is going to help produce estrogen and progesterone for a period of time after ovulation occurs to help sustain the endometrial lining as well as make sure the egg cell is equipped to be fertilized. This again is under negative feedback, so as estrogen and progesterone levels go up, that's going to cause a decrease in both FSH and LH, and as those two hormones go down, that will eventually cause a decrease in estrogen and progesterone. So it's the same type of homeostatic negative feedback mechanism we saw before in males, but now we're looking at females. All right, so like I said, for about a week after ovulation, the secondary oocyte is available to become an egg cell if fertilization occurs. If fertilization does not occur, if there's no pregnancy, then the corpus luteum starts to break down about a week after ovulation. And as soon as that happens, as soon as that corpus luteum starts to degenerate, levels of estrogen decrease, levels of especially progesterone decrease, and once they get below a critical threshold, that's going to stimulate the beginnings of menstruation. All right, so the endometrial lining will be lost, and it will start over back with day 1 in the next month's menstrual cycle. So that's day 28. Once that occurs, once estrogen and progesterone go back down again, that's going to result or allow for the next month's increase in production of GnRH, LH, and FSH, which then begins the next month's cycle. So it kind of repeats after that point in time. All right, so this is first thing we're going to do is we're talk about this graph here, this picture, because it's got a ton of information on it. What this is showing you is sequentially all the different things going on during that 28-day menstrual cycle. So we have GnRH production, we have FSH and LH on the second kind of graph, we have kind of an image of what's going on in the ovary, we have ovarian hormone levels, and then we have the uterine lining, all happening simultaneously. And so we're going to kind of go through this. The way you ground yourself in this picture is by looking at the numbers. That's kind of how you keep track of what's happening when. Okay, so the beginning, day 1, day 0 of the 28-day menstrual cycle, we have an increase in GnRH. As GnRH increases, that's eventually going to cause a big increase in LH and FSH, but we're not quite there yet. Okay, as these hormones are increasing, that's going to allow for a continued increase in the development of the follicle. Now, as the follicle gets bigger, as it develops, as it becomes more substantial, that's going to allow for an increase in estrogen production. So we see we've got GnRH, we've got FSH, we've got follicle development, and we've got increasing estrogen. And what those things are doing collectively is they're allowing for the maturation of the follicle as well as the beginnings of the production of a thicker endometrial lining, which could eventually receive a zygote if a zygote is produced. Okay, so now we're going to kind of jump out here. We see this peak of GnRH production, which results in a spike of both LH and FSH. And as these two hormones go up, there's also going to be an increase in estrogen production. Now, when these three hormones peak, that's going to allow for several things to occur simultaneously. The main one being ovulation. Right? Ovulation occurs as we hit this spike of LH, FSH, and estrogen. Once that occurs, ovulation is the point where the secondary oocyte's been released, and now the clock is ticking for pregnancy to occur, for fertilization to occur. So immediately after ovulation, there's going to be a big drop-off of GnRH, LH, FSH, and estrogen. All three of those drop off very, very quickly following ovulation. Once the corpus luteum picks up, however, the corpus luteum then is going to start producing its own estrogen and progesterone. So we see progesterone pick up and eventually a recovery of estrogen as well. The purple line is estrogen. That's going to increase as well once the corpus luteum has matured and begins to produce its own hormones. And of course, what that does is allow for further endometrial thickening over here in anticipation of that zygote being produced. For about a week, we now have a situation where fertilization could occur. If fertilization does not occur, the corpus luteum begins to break down. And as this breaks down, that's going to see a drop-off in progesterone and estrogen. And that will therefore eventually result in the breakdown of the endometrial lining. And that's going to result in menstruation. Once those hormone levels drop, once the endometrial lining is lost, then we're going to repeat back over here with an increase in GnRH and eventual increases in FSH and LH. And that's going to start the next month's 28-day cycle.